Patient. Good morning, everyone. Today is March 22nd, 2025. We are on the Saturday morning, 9 a.m. And the plan for this session today is a lab 3, second week of the lab 3. On the lab 3, the plan was to take 14 pictures from the uh, gas giant, one of the gas giant like Jupiter, Uranus, Neptune, and uh, Saturn, and get the orbit and distance between the moons of this gas giant planet, outer planet of the solar system, with the planet itself. Therefore, the idea is that to get the investigate the Kepler laws that introduces the identification of the orbit of the two-body celestial body, either planet around the sun or the moons around the planet. The reason that we didn't use the uh, planet around the sun because the planet may takes longer time to revolve around the uh, sun itself. For example, Earth takes 365,
Mm.
uh, Jupiter takes many more, and Saturn also same
Mm.
thing. Neptune many tens of the years, and Pluto is 248 years. Therefore, if we are going on the lab, our lab gonna be 1 or 2 week. On that 1 or 2 week period, we cannot able to catch the significant portion of the orbit to investigate. Therefore, we focus only on the two body that is one of them is planet, the big planet like Jupiter, Saturn, and Uranus and Neptune, and one of the biggest moons around it. And the reason for that is that we're able to make it in 1 or 2 week significant movement of the moon around the planet. And because of the condition that we have on the sky, Jupiter and Uranus is the best option. Therefore, we recommended last week to start with those two. We recommended to have 14 of them. 14 of them out of the 14, maybe some of them is not suitable. Either moon goes beyond the planet or goes on the front of the planet. We cannot measure the distance based on this procedure that we have on the Skynet. The only option might be out of the 14, if you have 5 or 6 or 7, gonna be good enough to get the very proper values for the orbit. That's a very brief discussion of the item that we're gonna start today. And John, if you wanna add something on it, and we go to the measurements tool and uh, operation step by step on the this week.
Yes, and I know Rui, you joined us tonight. So if you or Mohammed, either of you haven't started the observations of Jupiter, we can set you up real quick to make sure you've done that and get that rolling. I know it does take a while. My Jupiter and Uranus, I'm only about halfway through my observations. I got like 6 out of 14, 7 out of 14, just because it takes a day for each observation. We're doing this over 2 weeks. I did run a fast one. I thought just for fun of it, I'd do one every hour to see how the moons change, just for my own reference and for future classes. And even then, that one is taking a while because I think with weather issues in different places and just how it works, sometimes you don't get all those observations in a row. So I got a whole bunch last week, then it seemed like it stopped. And whatever telescope, I'm waiting for it to get caught up again to get those observations. I think another observation I talked to, I think it was Rui or somebody this week, and they're discovering that on these telescopes, when we take the images, some have a smaller field of view than others. And so, like some of my Jupiter images, I'm not going to be able to use because it captured that telescope, put Jupiter at the edge of the image. So I have Jupiter, but I've lost half of the sides. Like I don't know if there's any moons over there. I don't know if I can catch Ganymede or not. And so we're only focusing on one moon of Jupiter, just Ganymede, which is the biggest. It's a huge, huge moon, and it's at about midway in the path. It's not the closest. It's not the farthest, and it zips around pretty quick. And so each day we should see a change in position. So if you don't see it, it's possible that it's off your screen. because of the size of the screen that we're looking at. Or it's possible it's behind the Jupiter, which then tough luck, or it could be in front. So I always look for shadows on the surface of the planet if I can't see it to the sides. So I don't know how everybody else is doing with their observations, but it is nice that you don't have to wait for all 14 to get done. If you have any images, in fact, we can use the Jupiter image from earlier on in the year to kind of go through this process today as far as how to measure things. And that's the big thing for the exercise is be able to measure out the distance this moon is from Jupiter. And the same thing for Uranus also, that we can use moons and how they go around, thanks to Kepler, we can figure out the mass of the planet to some precision. Since we are scaling it to the sun, we're going to have a lot of error, I'm anticipating, but it's just crazy to think you can do that. And honestly, I think it's so cool that we really don't know any better than what we're doing this way, unless you send a satellite to the planet and have it orbit around it. That's like, then you get the data, then you get to actually what it is. But you can't put a planet on a scale, and you can't put anything on a scale like these gigantic. You just can't do it. Only we can do it is orbit them and watch the orbits to figure out what the mass of the central body is. So I think it's amazing we can actually do it. And that's what this lesson 3 is largely about.
Thank you, John. There was great notes that you provided. Some of the pictures may not be good enough, therefore we don't worry about that. But we go, if one of the pictures we don't see at the moon, just forget about that. Go to the next one that we're gonna show today as well. I have a few of them, and I have 11 of 14. Fortunate that I get
Mhm.
close to 14, but I will show you how it was. And also, I want to emphasize this one. This is actually the way that professional astronomer does. A sort, not exactly, but very close. That because how they get the mass of the objects, like if you want to have mass of the Jupiter or mass of the Sun, weight of them, and also the orbit of the planet. This is the actually. You think about that. You are a professional astronomer. You do it, or citizen scientist. You are not learned on the academy astronomy, but you are kind of passionate about that, wanna learn, and that's a very good tool that Skynet and UNC in Raleigh provided for all of us to engage in more professional way of the learning and also discover something that we didn't know that. And I will keep uh, less talking and go directly to the observation. I will share with you just quickly.
I'm going to say a couple things real quick. I'll keep the chat open as Abbas is going through things. I'll make notes in the chat. And then if you have it open Skynet, I would do that. We're going to go Skynet and then we open Afterglow really quickly as we start going through this. And what I love about this point in our lessons is everybody can do this as we're doing it. So before we're done today, you could have everything done or a lot of it done that you need to do.
Okay, do you see my screen? Let me check first to see if you are all of you you can see it because I don't see it the chat. I would like to see here the voice. Do you see my web assign
Yep,
page?
I see it.
Yes.
And about the Astromancer
Yep.
Yes.
and Skynet
Yes.
and the workbench. Okay, I will go. I want to make sure this is kind of programs that is created for the curriculum by UNCC, and you don't need it to download anything. I want to emphasize here on here as a step-by-step provided how to take a picture of the moons and the Jupiter or planets, and also the first thing that we're gonna do here, I don't wanna I wanna give you some high level things here. Here for each of the observation, you will choose the whatever moon that you, for example, for Jupiter is Ganymede, for Saturn is Titan, for Uranus is the Oberon, and for the Neptune is Triton. Probably Triton and Titan, we cannot see it, therefore our focus gonna be in these two to identify the things. And whatever information you get it from the Skynet, you can put it here and record it on this table, data table 1, planetary moons. And here it identify 10 points. here you have 14 of them, but you may not able to get all of them, but you will put whatever you needed and sign on your name. And that's going to be first table. And second table, we're going to go later here. This is a graph that created by the astromancer. The data that we get it based on the picture that we're taking is showing by the red dots here. And we're going to move the curve in a way that best fit the data that we have it on the observation from Skynet, the red dots. You see here, some of the dots is out, some of them is close. Uh, may not able to match all of them, but you just maneuver the curve on the astromancer. We're going to go over this procedure as well to make it better fit. And when we have a better fit, is actually we're gonna get the period of the moon around the planet, and also semi-major axis dimension A. And you don't need it to calculate here like this here. The program it's gonna show you, and I'm gonna show you later on. And when you done that, you put on the data here on the web assign, and then based on this formula that is provided here, you calculate how much the uh, um, values for the orbital values that you have for the A based on the astronomical unit, semi-major axis of the Ganymede, for example, and also you get the uh, value for the mass of the planet. This is an M that you're going to calculate here. It's going to be mass of the Jupiter versus mass of the sun. And here, for example, this is a number. You see it as an example we provided. And finally, you convert the planet mass to the mass of the Earth based on this kind of proportionality. You see here, finally, you get the mass of the um, planet 221 times, or you will get different numbers. Shouldn't be exactly the same number that I showed to you. And the last one, you get the total true mass of the planet in Earth masses compared to the error that you have it. Here you see you have 30% error, or you will get lower or higher. You may get 70%. You may get 20%, 10%. Those shows how much accuracy in our observation it happened. And neither of them is right or wrong, but it is the way that this error might cause on the observation. And last part, I don't think we're gonna reach to that point, is related to the um, measurement of the um, Venus phases. Because Venus may not be able to take it, but this is provided for your own sake if later on you do observation on the session that we have on the May or so, or anytime within the next few months, you're able to do that. You can exercise this experience as well. As I mentioned, we have some points and grade on the uh, session, but this point and grade is not to mean that you fail or you pass. But this is just make it in a way that you learn something and you find out the observational data. Okay, this is very brief view of the what we needed to do. Then actual things that we have to start. We have to start with this two program. One Skynet, one Afterglow. First, I will go to Skynet. Probably you open up. I see the observation that I made it on March 2025. It is active. Yours might be active or might be active 5 of 14 or any number here. Mine is, this shows that 11 of the picture are already completed. When I click here, it only show the pictures, probably picture of the Jupiter only. It shows on the left, as you see it, all of them has some numbers on it. But here we cannot measure anything. This is just a pictorial view. After you done, you don't need it to, as John mentioned, we don't need it to wait 14 of them done. You start to do the calibration. But it's better you start uh, after a few days. After a few days, you start in 4. You collect the data. After a few days, you become 8. Collect the data. After a few days, become 11. Collect the data and get the sorted out information as needed. And for here, you just click the. Go ahead.
Could you take really quickly through the setting up of the 14-day observations in
Oh,
Skynet?
yeah. I think it's better to do that. Yeah. I will go one more time on here. If you go here,
Thank you.
you're welcome. Thank you for reminding, John. Then if I go, sometimes it takes time right now.
It's one of the advantages of being a small group like this is we can kind of help each other get through this as a work session. So Rui,
That's
if you
good. Yeah.
Rui has Skynet open, we can go ahead and do the target lookup and get you set up.
Thank you, John, helping out on the chat because I don't see it and may not catch the response on
Do you
the question that
mind if
everybody
I
has.
share my screen and just take her through this real quick? Because you've been doing it, that'd be one for me to run through.
No, I will. If you're gonna go ahead. Yeah.
Yeah, I'll go and do it real quick. All right, so my screen's showing okay?
Yes.
Yes, that's good. Thank
All
you,
right,
John.
so in Skynet, we're going to optical observation. See, and then I go to add a new observation. And we're going to look up Jupiter. And so I hit the search. And right now it's set on the daytime because that's where we are. So I'm going to go up to the hour setting and start going backwards or forward one way or the other until Jupiter is going to come around here. I see Mars. There it is, Jupiter. All right. So it's up at night. Oops, I went too far. Okay. Uranus and Mars. I don't see the moon near it. That's awesome. And then I'm going to scroll down here and I've set the amendment target elevation at 15. What that does when I come to the bottom here, it sets this bar down here at 15, and it really lets me see all these telescopes are available. I'm gonna go ahead and increase that. I could increase that to 30. I'm gonna increase that to 20. Just make it a little bit higher up. Make sure there's a little more separation, maximum sun elevation. Kind of depends how desperate I am for the image. The moon separation's at 30. It's been visible for an hour. Maximum sun's under the horizon, so past the twilight. And I come down. Everything looks really good. I've got a whole lot of telescopes that are available. And for this exercise, it doesn't matter so much. So I'm going to go ahead and save and choose the filters for this. Okay. And I think mine's already set. And I believe, Abbas, we're doing the V filter, I believe, on this one. Yes.
That's right. We for this observational lab 3 for the Jupiter, we needed V.
And so Johnson and Cousins, I go down here, I hit the V link. And that way the filters are set up. And if that looks good, I'm gonna go ahead and hit save and continue. All right, so once I've done that, I can look at what telescopes are available, and there's a whole bunch of them. If I hit the little yellow bullseye here on the right, it'll actually pick them all, or I could decide which ones I want. For this exercise, I'm just gonna let them all be open. It doesn't really matter to me. For Jupiter, it's a nice bright object. If it's a darker object, you might think twice. And so at this point, I've picked them all. That all looks good.
And also one note, sorry, interrupting John. As you see it here, or each telescope, if you look through each telescope, for example, first one, OPIS, it gives some diameter and also field of the view.
Yes.
That field of the view that we discussed this few minutes ago, that you mentioned that sometimes the Jupiter goes to the edge and are not able to see it. And some of them you see 10 arc minute by 10 minute by 10 minutes. And some of them you see 26 by 26 RPP. Those are different. That's the reason that some of the pictures, because of many different reasons, goes to the edge of the picture and we're not able to see the moon. Sorry, I interrupt.
No, it's really good. In fact, since I'm zooming Jupiter, I took off the prompts because their field of view is so small. And I took off the one at Moorhead because that is down to 7.5. That's like no space. And I think I did get one of those and it chopped off the moons. And I took off the bottom prompt also. I'm thinking for Uranus, it's probably okay to use them all because it's so much smaller in space. But for Jupiter, it's a lot closer. So once I've done that, we can hit save and continue. Okay, and then choose efficiency. And I'm at optical observation. I want to pick this generic 16-inch. That's our default. And the program is going to go ahead and adjust everything for me. Okay, now when I go down to add exposures, even though we want 14 days, we're only going to do one exposure per day. So we don't want to do 14 exposures over 14 days. That'd be a whole lot of observations. So just one, and I have in here 0.03. I'm not sure if that's right.
That's right. That's right. For this
Right?
moon, 0.03 duration for the moon observation.
Very good. Okay, and I've got some credits left, which is good. Now here's where it gets interesting. Down here in advanced options down here, this is where I need to click on the repeat this observation, and this is where the 14 goes. Repeat this observation 14 times with at least 1 day between these. So for this one, we want every day to get just one image. Now, if you ever wanted to play around like I am, you can change this to hours and minutes, but I want to keep this at days. And then we're going to hit save and continue. So doing good out there? Good? Rui, you doing all right? Okay, good. Okay, I hit save and continue. And I just do a quick review. Sun's going to be under, past twilight, 20 degrees minimum. Moon is going to be separated out 30 degrees at least. I got my telescopes. I got my exposures. It'll take me 14 credits. Hit submit, and this one's ready to go. And so good chances are tonight and the next 14 days, it'll take observations. Now, since I did deselect some of those that have small field of views, I may not get an observation every night because of clouds and all that. I'm aware of that. If you pick them all, which I definitely would do for Uranus, you're going to have probably one image every night, almost guaranteed.
And also one reminder that make sure that you put some good target name for the observation on the top. That, for example, if you put it Jupiter, probably it's going to be later on when you're going to come. If you took it Jupiter several times, you don't know which one is which one. Therefore, you have to check one by one to see which one is correct. But if you add some kind of notes of the observation name, it's going to be easy you to find out what you needed, what you intended for lab 3.
Thank you so much. I always forget to do that. It's all
Yeah, me either. I always forgot, but we have to keep remind ourselves that it is make sure that we identify that name very good for later investigation.
Yeah, that was good. And now I changed the name. So now when I'll go back to the end of the review at the top. And now I look at it, actually has a name that I'll know what I'm doing. Oh boy, slow learner here. But then we hit submit and it's good to go. And then your observations start to go. So tonight we'll have an observation. And if you do go back, I've already done that. So I'm gonna go back to my optical observations. And I can pick that Jupiter we did from back in January for today to go through the measurements we're gonna do this here in a moment. All right, so back to you, Abbas. Oh, you're muted.
Yeah, thank you. Let me go to the observation. I recommend for this observation to create a Excel file. The reason is that this Excel file is going to help you out. For example, I put 14 rows for my observation. I put some title for myself. You don't need it to submit this one to the web assign or do something, but this is going to be helpful in the process of the working. Do you see my Excel?
Yes.
Okay, yeah. Therefore, here I put one column for the number of the observation. I put 14, and here the second one is we're gonna put based on the Julian day and separation. We're gonna go how we calculate this one and the time of the observation. You see, my time is started March 12 right now. The last one that I have it probably 21st of the March is actually yesterday was that. And you see one of the picture that I marked here, the Ganymede was behind the Jupiter. Therefore, this one not gonna be I cannot measure it. Therefore, I just mark it differently to identify that. And the parameter that we're going to check is A and P that we're going to look through it later on the next activity. If we go back to do you see my other page, Skynet and Astromancer?
Yes.
Okay, yeah. Then on the observation, as you see it, as we explained it, we had 11 picture here. I click Afterglow for this on the Skynet. I am on the Skynet and my observation on here. As I see it, I checked all of them available, but I don't want to review those. We cannot do anything on here. The next step, we go to the Afterglow. For Afterglow, you click in here. You see, again, I showed to you on the same page that we have my observation. There is an icon here on the right side under the mark. This is the observation list. There is a one line tab exists. They call it Open Afterglow. When you see Open Afterglow, it open up Afterglow. But I open many of them. Probably you see my Afterglow as well. Do you see Afterglow page?
Yes.
Okay, then on here I uploaded, but when you open it, you don't see it anything about this observation. You need to go here. You see this open file icon on the top left?
Yes. Yes.
Yeah, click on the open file, and then you go to the Skynet Robotic Telescope Network, and then go to the user observation. This is user means you. Therefore, I will repeat again one more time. Open files, go to the open files. When you open the file, it's gonna come here. Then click the Skynet Telescope Network and user observation. This step already showing here. When you open file, you see the files is here. Robotic Sky. This is a folder of the Skynet Robotic Telescope Network, and this is user observation. User means you. When you open yourself, anybody open it, it shows his or her network here. You can look through it. You may have few of them. I have many because I did it for last year many times. Here, you just put your observation that you want to look through it. Jupiter something. When you say Jupiter something, it brings you all the observation that I have for the Jupiter. Probably the one that I have at 11 probably is this one. This is Jupiter Moon AM, my initial March 25, and this is the observation that I have. Click on this. When you click, only choose the reduced images. We have raw images, we have master calibration images. Those are provided for astrophotography. But the final product that the afterglow is reduced the noise and make it proper for the observation is the one that they call it reduced images. This is the one that is processed by the afterglow. You don't need it to do anything. You have to open it only. When you open it, you see 11 pictures here, and each of them taken by different telescope. Here, for example, prompt 5. Most of them is prompt 5. This is APOS on the Virginia, and this is Arkham, and this is prompt more number 1 is probably on the Raleigh. I don't remember the names, but you can check it. If I make a mistake on renaming, you will check it. It's not important to know which one is which one, but it gives some big hint what the observation done and how it works. Then you come and select all of them. There is an icon here. When you click on the top left, it select all of them. When you select all of them, click open. When you open, it's gonna upload these pictures on the Afterglow. It takes a while. It may take a few minutes or so on the opening the file on the Afterglow. I cancel it here because already I opened. As you see it here, the pictures I will show you to make it all of the pictures available here. This is one of them. This is the other one. This is another one. You see the orientation of the moons are different for each picture. You see them?
Yeah.
Yeah. Here, for example, you see a line is happening here. This line probably is a satellite or something. It is coming through the picture, but at least we can see the moons. Therefore, this is not too bad. Here another picture. Here another picture. You see the every picture has different orientation of the moons on the here. And on this observation, we have to do this works step by step. First, I will remind you on the afterglow. First, on the upper right, you have a display option. This display option shows the graph of the light on the picture. This is the highest point is the Jupiter, and lowest point is it is kind of light curve through the picture from here to there. And next one is important for our lab here. It gives you some information what we have here. The information that we have here, the most important one that we needed to for the graph, one is the center time. What time is the taking the picture? Another one is the Julian day, uh, center Julian day. This Julian day is based on the mm, time around the 4,000 years before the um, Christ, BCE, that is created as a kind of measuring the number of the days from that specific origin. But the reason is we using that, we don't use it the central time because central time is very difficult to identify on the graph. When we're gonna get the graph, it is based on the moon, based on the month, year, and the day and time. And this is very difficult to get some basic graph on those. For example, if I go here, if we're gonna get a graph, for example, the graph that we have here, this one is a kind of on the number of the days has to be a numerical value. But if we have months, days, and hours, and minutes and things, it's very difficult to do that. Therefore, this Julian day is created because of that. And I sent some the explanation last week how the Julian day is and how they calculate it. And I give some link for how to calculate the Julian day based on that. But you don't need it to calculate yourself. This is calculated directly by the afterglow, and you only need to copy and bring. Remember, this one is the the 22nd observation. Let me go to the beginning. This is the first one that I did it on the March 12th. This is the first observation. I copy this and go back to my Excel. Do you see my Excel? Then
Yes.
I
Yes. Yes.
copy. Then I copy here. When I copy here, this is the first step that I do. Copy the Julian date that I have it here. And then the date, I copy the date. I go back to the year and copy the date of the picture. You remember here, this is GMT, unit is not our time. It is based on the universal time, Greenwich time, Royal Observatory. And I copy this and I back here, sorry. I back to the on here and copy paste here. Okay, therefore this one is important because next step we go to calculate the separation. We get this data is already done. We get this data copy from the afterglow. We don't need it, this one. This is just for our information. For the taking the graph, we don't need it this, but we needed this two, Julian day and separation. The Julian day is kind of goes to here, and separation goes to the vertical part of the graph. Therefore, on here, on the Excel file, we needed to calculate next step, what the separation is that. I go back to the afterglow. Here, the first one, I need to know where is the Ganymede. Here I see, I know this is Jupiter, but I don't know the Ganymede. Therefore, I have to play with the saturation level here to show it very precisely the moons, where the moons are located. I think this is good enough. I little zoom it in. The reason that I'm zooming it because I understand the Ganymede is located very close to the planet. I do it, let me see. If I go, I have this information ready. The next step, I go to the stellarium. The stellarium is gonna be, let me stop sharing. Go to the stellarium on my computer and open up the stellarium. Let me share it again. Okay, I hope you see the stellarium in my screen.
Mm. Not yet.
Okay, let me share it again. Yeah, right now it's become better. Hopefully you see it at the moment.
Yes. Yeah.
Okay, here, as I mentioned, the stellarium, when you open it, the one that is has more information on it and better is the one that you downloaded on your desktop. You see it, it occupy whole screen. The first thing that you needed to do to bring the whole screen a smaller size to able to maneuver between the pages. You have to come to the lower left corner. You see an arrow here. Probably you see it. You
Yeah.
see this one?
Yeah. Yeah.
Then there is a two smaller black arrow. You see it within this. It's very small to identify and very hard to find. But you know, you have to click on this arrows. I click one. You see arrow complete transfer it to a square. Then you click the arrow again. It become two square. When you do that, the next step you go here. This is full screen mode here. You clicked on the full screen. What happened? It reduced the size and zoom out. And therefore you are able to do that. The reason that I did it this one, because I needed to have both afterglow and stellarium in one sheet on the screen of the page of you have. If you have two screen in your home, you can be put it one of them in one screen, another one to other one. But here I bring the afterglow. I close this one. I reduce this one and I see the location of the small planet. Okay. The time that we had, I want to see what time we had. Time that we have here is Central Time, is March 12, 0.027 after midnight on the Greenwich time, UTC. The first thing that you needed to do, come specify the location. Here, when I locate it, it says is some location, random location, it provide America. But here, two things you can do. You put here Greenwich, and you see on the top Royal Observatory Greenwich. Then you click it. When you click it, it's already provided based on the Greenwich time. The next step, you go to the time. What time we have here? 12 of the March. Therefore, I come 12 of the March. And what time is it? 0027. You can type it here, 00227. Second is not important because it's always changing. You cannot make it very clear on that. The first thing you just identify, make sure to identify the time, because when you go, every page is going to be different. If you miss it, you may miss it the orientation properly. Then you come next step, you show the Jupiter. Here, probably it shows wrong direction because let me see, it's 12, this is 0.27. It should be right, but probably something is incorrect. You see, the problem is incorrect because I specify Greenwich here, but it doesn't apply it. You have to click it sometime, it doesn't happen. When it doesn't happen, you come here and identify UTC 002. Again,
You're not sharing right now, boss, just so you know, we see us.
okay, just hold on a second, I share it again. Thank you. Okay, do you see the screen right now for the Stellarium?
Yeah, so UTC should be UT002 or just
Oh,
40?
40.
Oh, yeah.
40. But you have to click it to make sure that it's catch it, the things. You close it, and I recommend to go back again, see it is implemented. Therefore, it's already taking care of it. And then you come to the date, and here is 00. See, become dark. Before I try it, it doesn't go. Make sure that you check it step by step, what the date and the hour and minute. You can check it. You see the afterglow on my right screen and the stellarium on the left. You see both of them on my screen. Am I right?
Yes, yeah.
Yeah, here you just specify the March 12th here, and you specify date and time, hours and date, hours and minute here. I said doesn't matter. This is always changing. You cannot change it. Therefore, you just specify the location, hours and date, and then you come specify the object that you want to see, Jupiter. When you specify the Jupiter, it bring it on the location probably. Let me do it again. It doesn't show. Strange. Let me do it. Sometime it play.
I had to turn off the atmosphere and the ground for mine to show
Oh
up
yeah,
on.
yeah, yeah. You're right. Yeah, I have to turn it out that one because that way it's easier to see it. Make sure that you turn off this is ground. When you have this ground and the trees around, you cannot see it. Therefore, you always turn on this one, and always better to click. This one is not click. This is a telescopic view of the sky. Then you see it, Jupiter. Zoom it in, getting closer. Okay. As you see it here, where is the Ganymede? You see the Ganymede? Anyone?
Mhm.
Ganymede is this one, right?
Yeah,
Yeah.
bottom there underneath. Really
Yeah,
close
it is
this time
very
too.
close and underneath. And the one that is far away, Callisto, and another one is the nearby is you. Therefore, we need to identify this one on the or sky glow. This is gonna change, but we cannot stop it at the moment. But we go back to the afterglow. I enlarge it a little bit to see better. Do you see my afterglow?
Yeah.
Okay, then I just click the first observation that I have. Then I want to see which one is the afterglow. It's going to be very close. Therefore, I have to go here and we play with the faint object and change the saturation in a way that I can see the two close moons nearby. And I have to zoom it in a way that I see it very close object to it. I just not do that. Okay. I don't see it. I try it more. Finally, I found it. You see them?
Yes.
You see, it takes time, you know, to you don't see it. You have to play because if you play this one, make a saturation more higher, those are going to be disappear. Therefore, you will see it here. Then you just zoom it out a little bit to see the Callisto. This is the Callisto, and I will make it this one a little bit like this. Okay, here you see the Callisto on the left and the Ganymede and the U is here, but we don't know which one is the Ganymede. We are too close. Therefore, we have to match the orientation on the stellarium. I share the stellarium. Do you see the stellarium again?
Yes.
I go to the Jupiter because it goes away. Okay, here. I zoom it out. The orientation is like this, here. But on afterglow is like not like that. Therefore, you will rotate it. Although rotate it, you don't see it the actual orientation, but you can come up with kind of orientation that you may have. Then you have two moons nearby. One on the upper, one on the lower, one on the, I will say, let me rotate it this way, one on the right, one on the left. Then you go back to the here. Which one which one is Ganymede?
Left, I think.
Yeah, let me make it enlarge it
Mhm.
again. Ganymede is the one on the left. Is that right?
Yes.
Okay. Then I learn enough and then go remaining task, go back here. Therefore, the left going to be Ganymede. This is going to be Ganymede. To get the separation that we needed here, the next item here that you see it, we come on this afterglow. We go to here we are on the display tab. We get the data from the time and the Julian day from the second one from the top right. And for the get the separation, we have to click the fourth one. It's called plotter. Here we have some icon that here is very important. One is the centroid click. Another one is the planet centroid. Centroid click, it means that when you click any object here, it gets the centroid of the object. We're gonna use this one to find the centroid of the Ganymede. And this one, planet centroid, is using for the getting the centroid of the planet itself. But we have to make sure that we do it step by step. Here, first we do the centroid of the click because we're gonna click the location of the Ganymede that is on the left side of the Jupiter. We go scroll down the mouse and we identify the centroid of the Ganymede. You see this centroid is already clicked. But before any other click, we go back with the mouse and identify the planet centroid and go back to the screen. You can click any place on this planet. The reason is that when you click here, when you identify on the right planet centroid, for example, I click here near to the edge of the Jupiter. What he does after glow, it goes find the actual best representative location of the centroid of the planet. Therefore, this is very important. First, for the Ganymede, you click, you don't specify both of them. First, you specify centroid click. You click on the Ganymede. You go back in the right side on the plotter. You click, specify the planet centroid and go back, identify the centroid. When you do this step, it gives you the separation. Separation is given here. You don't need it to do anything. Here, we have four numbers for the separation. The only things that we needed, this is center one. We needed to check based on the arc second. Then we copy this one and go back or uh, Excel file and paste it here. Therefore, we complete all the data for one of them. We can do the similar thing for all others that I did it in here, that I have it in my record. But the next step, because one of them is I will say is not observable, I will hide it. Then I go and only specify this part. We needed this data only. We don't need that number. We don't need that UTC here. Only Julian day and separation. And we just copy and we go back to the Astromancer. In the Astromancer, do you see Astromancer in my screen?
Yes.
And here we have several options. The first option is a curve. Any curve that you can go there. But for the lab 3, for the moons, you have to click the second option here. You go to the 3 lines here on Astromancer on the top left, click on that and specify the moon. When you specify the moon, you may see some data. Therefore, you just remove them. And then here, copy. For the copy and paste, you use the Control V. You just do the Control V. Because you specified before, you just either Control C for the copy and Control V for the copy and pasting on the data. And you see all the data that I have 9 points is specified here. Do you see the graph and the points?
Yes.
Okay, this point that you see it, this is for each of the point that you have. For example, different values that for each of them it is specified by the points here. The things that we have to do is the one, for example, in here, originally you see like this. Nothing is a bunch of the data is scattered on the data sheet. The only thing that you needed to do, you have to identify what the graph is. You just click in here, edit graph labels. I just put a description, angular separation of the Ganymede from Jupiter. And data is for a Ganymede. And x-axis is here is Julian day. And angular separation is the arcsecond. And save. And here, as you see it, all the data is provided based on this chart label that I provided. This is the first step you needed to do. Then you come here, there is a bars here. You can move it like this or move it like that, and either of them you change it. The first thing that you needed to do, this is amplitude. Amplitude representative of the orbit, semi-axis separation. It shows that how much separation the Ganymede goes beyond the Jupiter. You see it goes up and up. You bring it as high as the highest point that you have. What's the highest point that you see it here? Or these lines that you had here. Therefore, you just bring it as much as closer. As you see it, very difficult to make it, but probably this is very close. You can change those number a little bit here. For example, 262 on here, 263 to match exactly as needed. This is the first step you needed to do. The next step to change the period. When you change the period, this make it the period match as much as closely to the data point that you have. For example, the reason that you have, let me, before you go to that, how many peak points you see it here?
3.
3 peak points. Therefore, we have to move at this second row to see 3 peak values. Right now, you see, I see 3 peak value, 1, 2, 3. But the thing is that they are not matching with that 3 points. Therefore, might be there is a phase difference exists. Therefore, I just third step, I will move it in a way that match it with most of the points. But it's very difficult again. Then it might have some inclination, tilt on the orbit. Therefore, you just try to maneuver with these numbers. to make sure that the numbers are matched exactly with this data as close as possible. You have to go back and forth between these numbers to make sure that you catch the correct representation.
Yeah, this is where I feel like an astrophysicist when we're messing with the data and looking for the trend lines on this to make it fit.
Yeah, you see, you cannot make it all of them attach exactly to the curve, but as close as possible. You know, has less error. As much as you get closer, the data they get it might be better. I think I should save it the previous one. It was better. But anyway, this is maybe a little bit time challenging, but anyway, here that you get it, I assume you have some more time to do that, but we are reaching to the top of hours. I don't want to spend too much on that, but you have to play it to see as much as you get the data might be good enough. Here, the period of the Ganymede around the moon is actually this value. You don't need it to calculate anything on the graph. You just copy this one and back to your observation, paste it in here to have some record on that. And the semi-major axis also gonna be the number on the graph, this value. This value, you copy this one and you go back on the Excel. I put it here. Actually, I have to put it here because I have to do some calculation here. Copy. And this is the values that I have it here is the data from the Astromancer. I get it. Therefore, this is based on the arcsecond, but this is based on the uh, days, Earth days. Then to calculate the semi-major axis, we need to have some calculation on that related to the things that I showed on the lab. If you come to the lab here, for example, you get the data that the one that I copied on here on the orange here, 7.4269. It's gonna be, you're gonna put it here on your web assignment. And you're done. After you finish this one, you're done. But you have to get the calculate the actual distance. How you calculate this one? You have to go to the find the distance of the Jupiter from the Earth. You go here on the Jupiter. Each of them is not very important. For example, in here, as you see it, let me enlarge it a little bit to see better. Okay.
Yeah,
Jupiter.
quick little note on that. Make sure you are picking up the distance from the Earth because that's where the observations are from, not the distance to the sun, because that'll come up also on that list of data.
Yeah, here you see a distance from Earth is given here, 5.106. If you change the date because you're taking different dates, those are a little bit different, you know, because distance is not always same. Distance from, but it's very little. For example, 5107, 516 on 3 digits. It's not very significant, or 5018. The 510 is almost same. Therefore, you will get at that value and come back here and calculate it based on the uh, information that's provided on the here. You just put the values here, 5.1087, and you go down. Here, based on this formula that is given here, we have a proportionality. If we measure the around the what angle from the total length of the circle, and you can get the circumstances based on that information. And this one gives you how much one arc second is corresponding to AI, astronomical unit of the planet distance. When you get this one, and then you go later on, you will get to calculate the actual A value based on the AI unit. This is the one that I calculated here based on the observation and the reference that is provided on the web assign. Then you put your answer here, and this one gives us some indication that Ganymede semi-major axis is about, for example, 0.072 astronomical unit. The number that you see it here is slightly might be different, and that is the kind of errors that may happen during the observation. But either 0.006 and 0.07, both of them is very good enough because it gives you some indication, an actual calculation that the professional astronomer get the value to sense of the how much distance a moon from the planet exists, and that gives us some information about how many orbital period of the what you call it moon compared to the days of the year is. For example, here you calculate this is based on the year. You divide it by the uh, number of the years on the days on the year of the Earth, 365.25. You see it is about 0.02 years. It means that within 7 days or 0.02 years, the Ganymede gonna move one time around the Jupiter. And that's also provide a very good indication of the what the period is based on the years and days. And on the last part, we're gonna calculate the mass of the Jupiter that we're giving on the first week based on the formula that we found it. You get the A value, you get the P value that based on the astronomical unit. A has to be astronomical unit and P has to be based on the year, Earthian year. And then you calculate the mass of the Jupiter. As you see it, mass of the Jupiter is about 6/10,000ths of the solar of the mass. And that gives a very good indication of the actual value. This is actual value. It is 3 zeros after decimal point, 95, but yours is 66, for example, or some other numbers, and gives you some idea how to calculate a very close value. Although this, you will say this is not the same as this, but it gives you a very good indication. You calculate the actual value that you have. And finally, you will get how much convert the Earth mass to the Earth planet mass to the Earth mass. Then you assume one solar mass is 33,000 Earth mass, and you will get the how much mass of the Ganymede compared to the mass of the Jupiter compared to the mass of the Earth. It shows around 221, but actually mass of the Jupiter is about 300 times more than the mass of the Earth. You see this very simple calculation, you will get a very good idea about the orbit and the mass, and you will get finally the error that you have. You may have many different errors that this error doesn't mean that your calculation is not correct or wrong. It shows very good that how much you are off the target, but you are very close. If you have also about 30% or 20% error, it shows that you have some idea. The Jupiter is how much several hundred times more massive than the sun. Any question?
Sorry, I have a question.
Go ahead, Mohammed.
Sorry. You had the numbers that was in those boxes that you shows with the green border.
Oh, yeah.
What's that number is automatically calculate?
No. The one that I, as an example, I put it over there.
Put it there.
But
Example.
okay. when I go myself, this is for the training purpose.
Training.
But it is for the what to call it, because I'm an instructor. They give us some option that you showed you, but when you go yourself on your web assign, you don't see anything. Then you have to put the numbers over there yourself. You calculate and put it there.
And also, how forgot? Okay, just I think it should be in the kind of part of this training. But how we go to the like those pages? What was the name, Master?
Weber sign?
No, the other one, the last one.
Astromancer.
How we can do?
Astromancer, I put the link on the email that I sent it to you this morning.
Okay, yes.
All of them answer. You can check it. Astromancer UNC. It comes up. You can Google it and check it.
Sure.
The link is already provided on the bottom of the email. You
Yeah.
can go directly there.
Thank you.
You're welcome. Roy, any question?
Also.
Yeah, I hope it's not overwhelming you, Roy.
I was saying, it kind of shows the limits of using parallax, using angles to determine these. That's why our error is so large, but it is quite an exercise to go through.
But bottom line is that you can easily calculate the basic thing that you're never able to see. You're able to do it yourself in your computer. That is amazing how this technology goes, and also amazing that UNC Raleigh provided that kind of opportunity as a citizen scientist, that each one of us or whoever interested to calculate himself like a professional astronomer, how much the orbit is and how much the period of the Ganymede surrounding the moon after 400 years after the Galileo that he just pointed on his historical page that last week John indicated. That is so amazing for me. But I hope you enjoy the same thing directly as well.
Sure.
Any question?
Everybody doing okay?
Yeah.
Okay, but just try to calculate this one, create an Excel file and do the exercise. And if you can share it, whatever graph you get it, the data might be a good idea to engage all others also in the group that do the same thing and we might get different knowledge. For example, one time I get 7.14, one time I get 7.41 day for the Ganymede orbit. You may get 7.5 or 7.2, doesn't matter. But it shows that you get very closer. It is roughly 7 days. Doesn't matter what the digit after that exists.
Because actually, if we put all of our data together, I bet we'd be pretty close. I'd be within 10% would be my guess.
I may propose something. I will ask everybody to get the data, and we get probably that is one of the key things that Dan normally does. We collect the data, for example, P and A, the period, and also the semi-diameter major axis of the Ganymede, and we just average them because each of them has some error. But when we average it as a collaboration between 5 or 6 of us, at least, or 10 of us, it gives a better indication averaging of the actual value, and we compare that how much that average gonna be had error. That's gonna be very good. Any question? Okay, hope you have a good observation and recording and the calculation, and hope you see you next week. Next week, I may not able to come on the 9 because I had a business trip out of the town, but I want to ask you to see if we can change it the time on the Saturday some other time. Is that with you guys? Is that okay? What other time of the day you can make it?
Yeah, actually, I'll be busy all day with the state science fair, although I could hotspot. But yeah.
Therefore,
Wednesday.
Therefore, if we can do it on this, we just instead of if we can come on Sunday next week on the 2 p.m. Will be great. We have 2 p.m. Sunday and Tuesday 7 a.m. If both of you can come on those, might be it is gonna be covered instead of that. Is that okay with you?
Yeah, Sunday is better. Yeah.
Okay. How about Roy? You can do it 2 p.m. Sunday next week?
I should be able to, yes.
Okay, perfect. Thank you. Therefore, next week, we're not going to have a meeting on the same time, but instead we just combine it Sunday and Saturday in one session.
Sure.
Please put on your notes, and hope see you next Sunday, and have a good and joyful observation and calculation.
Thanks, everybody.
Thank you
so much. Thank you
You're
very
welcome.
much. Have a good
Thank you.
weekend. Thank you.
Have a
Thank
good one.
you.
Have a good
Bye.
weekend.
Bye. Bye.